Now we have two variable, GDS, gross domestic saving, GDP, gross domestic product. It is a time series data for the period 1980 to 2016. Our target is developing causality model between GDS and GDP to check whether GDP causes GDS or GDS causes GDP. Before we start, we have to test unit root. Since most of the variable or time series data not stationary, to determine the order of integration of the variable, perform unit root test. Suppose our variable GDS and GDP as unit root at level, but after first difference they become stationary. That is I1. Now, after we test unit root, the second part we have to test configuration. Since GDS and GDP are integrated, let me write it here in the comment. Since GDS and GDP are integrated of the same order, we can apply the Johansen. We can apply the Johansen maximum Johansen Josilas JUES sorry, Josilas IUS maximum likelihood maximum likelihood method of cointegration cointegration to obtain the number of cointegrating vectors. Let's double check. Since GDS and GDP are integrated of the same order, we can apply the Johansen Josilas maximum likelihood method of cointegration to obtain the number of cointegrating vector. And then Granger causality, okay, Angel and Granger suggest that if co-integration exists, if co-integration exists between two variables in the long run, then they must be either unidirectional or bidirectional. Okay. Granger causality between these variables. Okay. So the configuration variable. So the co-integration variables can be represented by vector error correction model. Now, vector error correction model can be represented by the following equations. This is the equation which represent the Granger causality, where BI, II, AI, MI, and NI all. Let me just bidirectional, sorry. If the set of estimate coefficient on the lag GDS, AI coefficient are not zero, short-term causality, we call it the short-term causality, and the error correction coefficient Z star of EC1 and EC2 is significant, we call it long-run causality. Now all this here we can see ECT1 is the lag value of residual derived from the co-integration regression of GDS on GDP in equation 1. Sorry, GDP GDS in equation, let's put it bold, upper B, EP and GDS. Okay, in equation 1, and ECT minus 1, EC2 minus EC2T minus 1 lag error is lagged value of residual derived from the configuration regression GTS on GDP in equation 2. So how to get this value error correction term when we run regression model between GDP and GDS or GDS and GDP? Then from there we take the residual, then we make one period lag of the residual and put it in equation 1 and equation 2 as EC1 t minus 1 lag 1 EC2 lag 1. Now if the error correction EC1 in EC1 t minus 1, which is lag 1 in equation 1, is significant, meaning that GDS has a long run causality on GDP, meaning that if Z star significant means long run causality. If A significant means that there is a short run. If Z star significant, meaning that GDS can cause GDP long run. Now we have to apply the EVUs. Okay, now this is the data here, what we have in the data, and from this data we have GDP and GDS. Now we can run from this data, as you can see, GDP, GDS, two variables, we open them, so we can run vector error correction model because we have one integrated equation. I'll go to quick estimate bar vector error correction model, and I put the variable here. Let me say GDS and then GDP. Okay. The lag here we have to put 3 or 4 lag. Let me put it 4 lag. Everything now okay, vector error correction with this variable, so we have to run the model. Just click okay, and you get the output of vector error correction model as we explained before. This is the long run integrating error correction term, equation 1. From this equation we can derive the error correction term, which is ECT, EC1 lag 1, EC2 lag 1. We get this, the residual, then we put it as a lag, then we run the vector error correction model. Here we have two systematical equations, GDS, which is there, of course, when we run the vector error correction or var model, the variable will convert it to first difference automatically. This is equation 1, this is equation 2, and this is the independent variable. This is dependent, this is dependent. We call it systematical equation, and then we want to explain to see whether there is causality in the long run or the short run. We have to find the p-value. How to find the p-value? We'll go to proc, make system, order by variable, and this is the first equation because we put GDS as a dependent variable, so we have this equation, we copy it, and then we'll go to quick estimate equation and then paste it here. This is the variable we have, and press OK. This is the outcome. You can see this is the error correction, minus and significant. When we say minus and significant, statistically significant, it means there is a long run causality between the error correction, the ECT1 in equation 1 with GDS. This is here, we call it long run causality. Long run causality, and this one here we call it the short run causality, and this one here, from this part here, this is, we call it the short run causality up to here, sorry, okay, from C2 to C9. C10 represent the constant. Then what we have to do here, we have to explain or interpret this outcome, just in case. The error correction model when GDS, this is the error correction model, when GDS is the dependent variable, GDS has become the first difference, as you mean first difference, D GDS, because when you the variable convert in a vector error correction model converted to the first difference. From the above outcome, we can see the residual. As you can see, it's 50 minus 50.93 of one period lag 1. As you can see it here, lag 1. This is one period lag. GDS, which is the long run, one period lag, residual of co-integrating factor between GDS and GDP. That means GDS dependent variable and GDP independent variable. So C1 lag 1, which is here, C1 lag 1 negative, as you can see it, because p-value is statistically significant, because p-value is less than 5%, 4.3%, which is less than 5%. Then when the p-value is less than 5% become significant, means that GDP has long run causality on GDS. GDP, which is here, GDP has long run causality on GDS in the long run. And this is how to interpret the long run causality when the error correction term is negative and statistically significant. It means there is a long run causality on GDS, on the dependent variable. That it means GDP causes GDS in the long run, or exists long run causality between GDP and GDS. What about short run causality from GDP to GDS? We can also check. How to check short run causality? To check short run causality, we shall using chi-square value wild statistic, and to check short run causality from GDP to GDS. So what is the GDP? You can see that GDP coefficient, and you can see GDP coefficient 6, C6, C7, C8, and C9, which is for coefficient. If all the coefficient jointly influence GDS, the dependent variable, then we can say there is a short-run causality from GDP to GDS. How to check it? I'll go to view, because this is 4. I'll go to view, and this one here from GDP from 6 to 9. I'll go to view, coefficient diagnostic, wild test, and then we type C6 to C9. C6 equal C7 equal C8 equal C9 equal 0. Double check. This is the null hypothesis for GDP, lag 1, lag 2, lag 3, and lag 4, which is C16, C6, 7, 8, and click OK. Now we can see this is the chi-square, as I mentioned earlier, the chi-square corresponding to p-value. This is greater than 5%, which is 12.62% greater than 5%, meaning that we cannot reject null hypothesis, which is all these coefficient is 0, meaning that the GDP lag 1, lag 2, lag 3, lag 4 cannot cause the GDS in the short run. In other words, there is no causality between GDP jointly with the GDS. The second part we have to check for GDS. Okay, coefficient diagnostic while test, and then we can see here, we can see the GDS. This is the equation here. GDS 3, 2, GDS minus 1 with C2, C3, C4, C5. From C2 to C5. I'll go to coefficient diagnostic, while test, then I type the null hypothesis, C2 equal C3 equal C4 equal C5 equal 0. Double check. C2, C3, C4, C5. This is the null hypothesis for gross domestic saving, and we want to see the influence of these coefficient, these variables jointly, and their effect on GDS. I click OK. You can see the chi-square corresponding to p-value of 15.86, which is greater than 5%, meaning that there is no causality, meaning that there is no short-term causality coming from GDS lag 1, lag 2, lag 3, and lag 4 to GDS. So the question here, our decision here, the decision is that there is a long-run causality from GDP to GDS between error correction model when it is negative and significant, but there is no short-term causality from GDP to GDS. The other part here, we can discuss the diagnostic of the model and what is the specification or the efficiency of the model. There are three things we have to check. The model should not have serial correlation, and the model should not have arch effect, and the model should not have heteroscedasticity, and the residual of the model should be normally distributed. Then how to do that? I'll go to view, go to residual diagnostic, serial correlation. We have 4. Okay, this is not good. Let me try another one. If I put 2 as default, the same thing. So we have to use the same as what we put in the beginning, 4. This is less than 5%, which is the model suffering from serial correlation. The second part here, which is not good, residual diagnostic, heteroscedasticity, and there is no heteroscedasticity, which is good. Arch effect, we'll go to residual diagnostic, heteroscedasticity, arch, and then there is no arch effect, which is good sign. And finally, we'll go to a histogram, and we can see there is the data or the variable normally distributed. Now everything okay, but the problem with this model is the model suffering from auto correlation or serial correlation. We solve this problem in other video. We convert these variable into log or natural logarithm in order to avoid the serial correlation or solve the problem of serial correlation. Thank you for following the video, and we'll see you for the next video.